For today's lesson, we'll be learning about special right triangles. If you're following in your notebook, this can be found in Unit 5 on page 51. A special right triangle is a right triangle with some regular feature that makes calculations on the triangle easier, or for which a simpler formulas exist. A simple right triangle is a right triangle whose sides are in a particular ratio. They can provide a shortcut when answering some geometry questions, such as determining the missing side of a right triangle instead of using the Pythagorean theorem. Let's take a look at these theorems for the special right triangles. The first one we'll be looking at is 30, 60, 90. And the next one is 45, 45, 90. What these numbers represent is the degrees for the angles. As you can see, both triangles have 90s, meaning that they're 90 degrees, forming a right triangle. So let's look at this first one. What this is saying is when your right triangle has a 30-degree angle, a 60-degree angle, and is a right triangle having a 90-degree angle, the hypotenuse will be 2x. With the leg from 90 to 60 degrees for the angles is x, and from 30 to 90 degrees for the angles will be x and to the square root of 3. Now if we look to the 45, 45, 90, this is both legs of the right triangle equal x, while the hypotenuse is x square root of 2. Now I'll use these theorems to find the missing lengths of right triangles. So let's look at our first one right here. What it gives us the hypotenuse. So we have to find the sides for this. So it says AB equals CB, which are the legs, equal each other because it's 45, 45, 90. Then we have AC, the hypotenuse, equals 4 to the square root of 2. Since we're provided with that, we know, if we think back, we know that the hypotenuse is x to the square root of 2. So we know that x, or the number in front of the square root, equals x. So in this case, that would be 4. So we can now know that x equals 4, leaving, so 4x. So x equals 4 for the first part. For the next problem, what we're given is a leg, and we're told to find the hypotenuse. Well, if we think back, that we know this one is also x, and this one is x. So we know that x equals 7. So 7 can be put for this side as well. But we don't need that. We need the hypotenuse. So we know the hypotenuse is x to the square root of 2. And we know that x equals 7. So what we know is the hypotenuse x. So x equals 7 to the square root of 2. This is more simpler than using the Pythagorean theorem, because if you see 7 squared plus 7 squared equals 49 plus 49, which will give you 98. And if you do the square root of 98, you end up getting 7 to the square root of 2. Same exact answer right here. Now let's look at this next question right here. We're given 2 to the square root of 2. And just like the first problem, if you remember, x is this hypotenuse that they're giving. So x is always in front of the x of the square root of 2 for the hypotenuse. So we know that this side right here is 2, and this side right here is 2. Now, those are 45, 45, 90. Now let's take a look at some 30, 60, 90. So what we're given here, we're given the length from 30, 60 for the hypotenuse, and we're also given a leg 5 to the square root of 3. So if we see, we want to find x. So if we remember that this length right here is x. So what we can do, there's multiple ways we can solve this. We can do, since we know that the hypotenuse is 2x, we do 2x equals 10, divide by 2, so giving us x equals 5. So we could put x equals 5. And we can also know that because 5 matches up here, because we know that the length from the angle of 30 degrees to the right angle is x3. So you know that x equals 5, and we know that because it gave us right there. Let's look at this one for a quick second. We see we're actually given the hypotenuse, and now we're told to find x and y. So we know that the hypotenuse, we have to mark what we know. The hypotenuse is 2x, and from 90 to 60 is x, and from 90 to 30 is x3. So what we can do, we have to use what we know. So 2x equals 24. We'll take the 2, move it to that side, divide. Gives 24 divided by 2, which x equals 12. So we know we can write 12 since we know that. So we know one part. Y equals 12. Now I have to look for x. We're looking for this x value. So we're already provided with x right here. So all we gotta do is put it in. So 12 for x square root of 3. So now we know that x equals 12 square roots of 3. Now for our final question right here, all we have to do, we're given one of the legs and we're told to find the hypotenuse and the leg from 30 to 90. Well, we know that the leg from 30 to 90 is x to square root of 3, and the hypotenuse is 2x. And we already, since this one's 30 and this one's 90, if we do 180 minus 120, we're given 60. And we know that from 60 to 90, we have x. So we know that 9 equals x. All we gotta do is plug in x here. So 9 times 2, 18. So we're given x equals 18. Now we all have to find y. We can just take the 9, since we know 9 equals x, plug it in here, and we get 9 to square root of x to square root of 3. So those are just some problems for special right triangles. Hopefully this helped you guys, and I enjoyed making this video. Thank you.